In this lesson 1-4 we will be working with the properties of real numbers. By the end of the video and work time in class you should be able to say I can identify real numbers and I can use properties of real numbers. We're going to be working with a couple of properties, and in those properties we will be looking and working with equivalent expressions. The word equivalent should be review for you, meaning equal, and we have expressions which are math phrases where we do not see an equal sign. When we have equivalent expressions, then we have two algebraic expressions that have the same value for all the values of the variable. So you're going to see this in a couple examples that I'm going to use with the properties I'm going to go over with you now. The first property we're dealing with is the commutative property, and the commutative property works with addition and multiplication. In the commutative property, it's saying that changing the order of the addends does not change the sum. So if you're adding numbers, the order that you add them in does not matter. Same is true for multiplication. Changing the order of the factors does not change the product. I'm going to actually go over some examples here before I go on to the next slide. So using algebra, let's look at the commutative property of addition. So if I have A plus B, we know that that's the same as B plus A. So an example using numbers instead of algebra, 18 plus 54 is the same as 54 plus 18. So we're looking at two equivalent expressions here, 18 plus 54 and 54 plus 18, and also two equivalent algebraic expressions, A plus B and B plus A. And the same is true for multiplication. If I took the factors A and B, the product would be the same if I did B times A. That order does not matter. And if I chose some values instead of variables, like if I did 12 times a half, that's going to give me the same as 1/2 times 12. So remember, commutative is looking at the order. So you might want to underline order. In the second property, we're looking at the associative property, which also works for addition and multiplication. This is looking at the changing the grouping of the addends, and that does not change the sum. And changing the grouping of the factors also does not change the product. So in here, we're changing the grouping. You're looking at the grouping, where in the commutative, we were looking at order. So an example here, using algebra with addition, if I have A plus B plus C, and I'm going to group, I'm first then saying, if I'm following order of operations, I have to solve in my parentheses first, A plus B, then add the A to it afterwards. And that would be the same as if I still had A plus B plus C, but I started by adding B plus C, then added the A. That would give us two equivalent expressions. Using math and numbers, if I had 23 plus 9, and then plus 4, so I'm showing that using those grouping symbols that I am doing 23 plus 9 first, then adding the 4, I would get the same answer if I did 23 plus, in parentheses, 9 plus 4. If I did the 9 plus 4, then followed that by adding 23, it would give me the same thing. And the same is true for multiplication. If I did A times B times C, and I did A times B first, then multiplied that by C to get a product, I would get the same as if I did the B times C first, then multiplied it by A. So using numbers in this property, let's say 7 times 9 times 10, that would be the same as if I did 7 times 9 times 10 and grouped the 9 times 10 first. Properties of real numbers, now we're going to look at some more. specific ones. So we have commutative, we have associative, and these next properties, let's let A be a real number, which you know what a real number is from the previous video in this chapter. So we're dealing with rational, irrational. We're looking at identity properties of addition and multiplication here. Identity properties is when the sum of any real number and 0 is the original number, and the product of any real number and 1 is the original number. Because what this is saying is we want to keep its identity. This is key here. We want a number to keep its identity. So if we take a number, let's say any real number A, and we add 0 to it, it keeps its identity. It doesn't change at all. So if I took 5 3/4 and added 0 to it, the identity remains the same. It's still 5 3/4. Now, with multiplication, if I want to keep the identity, I'm not multiplying it by 0, I'd multiply it by 1. Because whenever we multiply by 1, it remains the same. Once again, it's keeping its identity. So if I did 67 times 1, the identity remains the same here. I'm going to have to fix my smartboard. There we go. So if I multiply that by 1, that identity stays the same. Okay. Another property we have is the 0 property of multiplication. And this is basically telling us that a product, the product of a real number and 0 is 0. So whenever we take any real number A and we multiply it by 0, it's going to equal 0. Any real number, such as 18 times 0, is going to be 0, no matter what. The product of a real number and 0 is 0. That's the 0 property of multiplication. And the final property we're looking at is the multiplication property of -1, which states the product of -1 and a real number A is the opposite of A. So whenever we take -1 and multiply it by any real number, it's the opposite of that real number. Notice I didn't say negative A, I'm saying the opposite of A. When you don't know if A is positive or negative, you don't say negative A, you say the opposite of A. So if I was doing -1 times 9, it's the opposite of 9. So it's the opposite. If I did a -1 times -9, that gives us the opposite, which would be 9. So now we're going to look at which property is illustrated in the statements. 31 times 0 equals 0. That'd be the 0 property of multiplication. And I'm just going to abbreviate here. When we multiply by 0, we always get 0. When we have parentheses grouping x plus 3 and then adding 6 outside of the parentheses, and then on the other side of the equal sign we have x plus in parentheses 3 plus 6, what we're doing here is we're looking at changing the expressions on both sides by the grouping. If we're looking at grouping, we're doing x plus 3 first on the left side, we're doing 3 plus 6 first on the right side. We're changing that grouping. That's the associative property, and this is specifically the associative property of addition since we're adding here. (5x plus 0) is the same as 5x. Whenever you add 0, it keeps its identity. That would be the identity property of addition. A movie ticket costs $6.75. A drink costs $1.90. Popcorn costs $2.25. What is the total cost for a ticket, a drink, and popcorn? And we're going to use mental math. Well, I see the values here that I want to total up. And I know to use mental math, I would want to combine 675 and 225 first, because with mental math, I know that a quarter and 75 cents gives me $1. So if I have $6 and $2 plus that other dollar, that gives me the $9 plus $1.90 to give us $10.90. So using the associative, I guess commutative, changing the order, and the associative by grouping and saying I'm going to add these first helps me do this problem quickly. That's that mental math piece. What can we do to make this problem easy? What is the simplified form of each expression? On here, on number 5 here, we have 4, and then the parentheses means times, 4 times 8 times n. So essentially we're doing 4 times 8 times n. Well, I can do 4 times 8, which gives me 32. So I have 32 times n, and that would be our answer. That's simplified. We don't know what n is, so we can't simplify it anymore. In this problem, we have 3 plus 5b in parentheses plus 7. What I would do is change the order using our property. 3, and it's not times here, it's going to be addition. So I'm going to erase that. 3 plus 7 in parentheses plus 5b. Now the reason why I did that is because 3 plus 5b, I can't simplify. I don't know what b is. So 3 plus 7, since I'm just adding them all together, I know 3 plus 7 gives me 10. And then I have 10 plus 5b, and that would be simplified because, once again, we don't know what b is. In number 7 here, we have 8 times x times y all over 2 times x. Now I'm going to kind of regroup this problem. So we have 8 divided by 2. And we're multiplying it by x over x, and we're multiplying that by y, which would be over 1. And we're going to work more with rational expressions later in the year, more difficult ones. But you can see the reason why I did this is because I know 8 divided by 2 here is 4. So I just simplified that. And I know in here, I know that if I have a value divided by that same value, that simplifies to 1. So that would be times 1. And we have times y over 1. Well, anything over 1 is y. Well, 4 times 1 is 4, and 4 times y, how would I simplify that when I write it out? 4y. Is the statement true or false? If false, give a counter example. For all real numbers, a and b, a minus b is the same as b minus a. That is false. You can check, plug in a number, put, let's say a is 5 and b is 6, plug it in. So I'm going to do that. A, which I'm saying is 5, minus b, which is 6, is the same as 6 minus 5. Is that true? 5 minus 6 gives you -1, and 6 minus 5 is 1. That is not true. This is why it is false. The commutative property will not work for subtraction or division. The commutative property, just like in our notes previously from this lesson, it works for addition and multiplication. And I accidentally wrote a little too low here, so I'm going to erase a little bit of this. So it says, for all real numbers a, b, and c, a times b times c is the same as a times c times b. So I'm changing, it looks like the order of the b and the c, I move those around. That's commutative. With multiplication, that is true. We know that we can do that with multiplication. Can you say I can identify real numbers and I can use properties of real numbers? Write a summary and reflection. Summarize today's notes in 2 to 3 sentences. Do you have any questions, and what are they?